So we finished a couple of exercises on the camera algorithm. And the reason why I had you do that is because without you making those calculations and seeing where it goes, the camera method is going, or the camera class is going to be an absolute mystery to you. So this is what I had you do. I had you label the corners of the world, right? The screen, and that's 00 to 500 on the X. And then down at the bottom it goes down to 1000, and the bottom right corner would be 500, 1000, right? And this is like the entire world. And then I had you put the ship on the center of the screen, his top left corner, right? So that's like 250, 500 right there at the top left corner. And then I had you draw the screen window around the ship, with the ship in the center of the screen window. I'm sorry, not the screen. Let me see. The inner window, we could say, right? The inner window. And the inner window is going to be 300 by 600. So then if we work out the numbers where the width of the world is 500, the height is 1000, the width of the inner window is 300 by 600, then that gives us the top right corner being 100, 200, 400, 200, and so on and so forth. Okay. All right. And so now we need to take a closer look and see what the update method does, right? So if we had this state on the screen and we're running camera update using the ship, right? So we're passing the ship to update. What does the camera update do? Right? Well, what is the camera class? The camera class, you might think of it as like a movie camera, and it's like moving around to different locations. No. The camera class is a class that describes an object. And what is an object? It's a set of instance variables. That's all it is, right? And so the camera class describes a set of instance variables, two of them, a x offset and a y offset. All right. And x offset and a y offset. And I went ahead, and if you run the update method, which is happening every iteration of the game loop, it takes in the ship, and based on his position, based on the ship's rect, it calculates the x offset and the y offset. And this here is the calculation, right here. X offset is equal to this expression. Y offset is equal to this expression, with win W and win H being the width and height of the inner screen, right? The inner window. All right. So let's go ahead and run through it. We got negative shipwrecked X, which is negative 250. Yes, negative 250. So that's negative 250, right? Plus win width divided by 2. The width of the inner window is 300. Am I right? Yeah, 300 divided by 2. And 300 divided by 2 is 150. So negative 250 plus positive 150 gives you negative 100. That's our x offset. Very important, right? Then we run the calculation for y offset, and we have a inner screen window of 600 divided by 2, so that becomes 300. Plus a negative 500 gives us negative 200. So our x offset and our y offset. Why is that important? Because if you look at your code and you notice when you're blitting all of your objects to the screen, you're blitting them using a different method, right? What are we doing? Well, you're doing this. All right. So we're running a for loop through the platform group, with P being each platform in the group, right? First iteration, P is going to be the first platform. Second iteration, P is going to be the second platform until it runs through all the platforms, and then it's going to end, right? And what are we doing for each platform? What are we doing for each platform? We are blitting the platform's image onto whatever camera.apply returns, and we're giving it that platform. All right. So since what we know about blit is that it takes in an image and a rect, then we can assume that camera.apply returns a rect. All right. And if we flip this around, this is the algorithm for apply. And yes, we return a rect. Okay. But not just any rect, a rect with adjusted values. All right. So we return the platform's rect right? But the x position of the rect is going to be the platform rect's x position plus the x offset, and then the platform's y position plus the y offset that was calculated in the update method, right? This -100, -200, right? So let's go ahead and see where our platforms are going to be blitted onto the screen after running the platform's rect through apply and having it return the adjusted rect. Okay, so we are over here on this first platform on the top right corner, right? What is the x and y of the rect of that first platform there? Well, it is the top right corner of the screen, which is 0, 0. How do you know that? Well, you can go into your algorithm where you're making your platforms. Remember, there's like a nested for loop, and you're making your platform objects and putting them into the group. Well, if you look at that, there's an x and a y variable, and they're both initialized to 0, 0. So then the first iteration, the first platform's rect is at 0, 0, and then we increment x by 32. So then the second platform is at 32, 0. The next platform's rect is initialized to 64, 0, and so on. Right? We get to the end here, and we set x back to 0, and we increment y by 32. So the next platform's rect is 0, 32, and we continue our way down. All right. So let's go ahead and pretend like this P, as we're running through the blitting, is that first platform. All right, because it is that first platform, and we're blitting that image, the platform's image, onto camera.apply of the P object. The camera apply is taking in that platform whose rect is at 0, 0, and it's returning the platform's rect.x, which is 0. And we're adding the x offset. What is that x offset that was calculated? -100, right? And then we're taking the platform's rect y, which is 0, and we're adding the y offset, which is -200. Okay. And we return that value. So this expression turns into -100 on the x, -200 on the y, right? The rect's x is -100, the rect's y is -200, and we return that value. We return that rect right here, right? So that first platform gets blitted, not at 0, 0, where it's rect's x and y described, but the rect that is calculated, that is adjusted by the camera apply, right? Which is rect -100, -200 on the x and y. So where does he get blitted onto the screen? He gets blitted off of the screen. He gets blitted over here, where this is our visible window on what we show the user. Okay, so this all the platforms are getting blitted, but this guy is not visible. All right, and if you go ahead and run through all these other platforms, you'll notice that we get the same effect. They get blitted into negative numbers, which means they're blitting off the screen. All right, so now what about if we take a closer look at this platform right here? Right? Where does he get blitted? Well, where is his x and y location? His x and y location on his rect is 100, 200. Okay, because like his absolute position on the entire world is 100, 200. We go ahead and run that platform. Let's say we roll through this for loop and we eventually get to this platform. Right now we're blitting his image onto what apply gives us back. We come over here to apply, and the returned rect is the rect's x position, which is 100, plus the x offset. And if we remember, our x offset is -100. So that calculation turns into 0. Right? The x position of this rect that's being returned is 0. The y position is py 200 minus the y offset, which is -200. That calculation turns to 0 as well. So the rect that is returned by apply on this particular platform has an x value of 0 and a y value of 0. So we get back to here, and where does that platform get blitted onto the screen? At 0, 0. And that causes him to show up on the top left corner of the screen. Um, and I think that's a pretty good explanation. And then if we go through any of the other platforms that would appear in the screen here, they would appear relative to this inner screen, not the outer world. And so one thing to note is that this ship is flying around the screen, which means when we run update, the X offset and the Y offset are constantly being recalculated, right? And since they're being recalculated, when we go ahead and apply, right, the apply is also like adjusting the position of where these platforms are being blitted onto the screen. So if we were going to like imagine this is our running game, the ship is running around the world, right? What's happening is the ship stays in the center of the world, and all the platforms that are being drawn are being moved around relative to where the ship is being, like the ship is stationary, and the whole map is being drawn relative to where this guy is moving. So if the ship moves down, then all the platforms are drawn higher up. The ship moves up, all the platforms are drawn moving downward relative to the ship. So again, this algorithm was like a breakthrough in video game design, huge breakthrough, and it's kind of hard to wrap your head around. But once you actually get down to the numbers, then you can kind of conceptualize what's happening in the algorithm. And if you're still not clear on it, this was something that I wrestled with for like 3 or 4 weeks. So don't feel bad about it.